Hello everyone, I'm Amodini. I'm a student at Indian Institute of Information Technology, Sri City. I'm pursuing my BTech in computer science, and today I'll be solving PYQs on the topic of circular motion. So the first question over here is, one end of a string of length L is connected to a particle of mass m, and the other end is connected to a small peg on a smooth horizontal table. If the particle moves in a circle with speed v, the net force on the particle will be. So it is directed towards the center. We had seen a similar question, right? So let's just say this is it. And then this is the particle, and then this is the length L. So we know that the centripetal force that is nothing but mv square by L. It is produced by the net force that is provided by the tension. So therefore, the net force will be equal to the tension. So the answer is option B. Okay, moving on to the next question. For photoelectric emission from certain metal, the cutoff frequency is V. If radiation of frequency 2V impinges on the metal plate, the maximum possible velocity of the emitted electron will be m is the mass of the electron. Okay, so basically they're asking, there is a cutoff frequency. Okay, don't confuse it with the velocity. We'll write this as something like this. Okay, V. And then if radiation of frequency is 2V, radiation V 2V, okay, impinges on the metal plate, the maximum possible velocity. Here we'll be conserving the energy. So basically it's nothing but half mv square maximum, because we need to find the maximum possible velocity, right? So this is the kinetic energy that will be equal to Planck's constant into the frequency. So v square maximum, this is the velocity, that will be equal to 2h frequency by m, and therefore taking the square root, it will be this. So our option is C. Okay, moving on to the next question. A solid sphere is rotating freely about its symmetry axis in free space. The radius of the sphere is increased, keeping its mass same. Which of the following quantities would remain constant for the sphere? Okay, so first of all, here what they are asking, that there is a sphere, okay, and it is rotating freely about its symmetry axis, okay? So let's just say this is the symmetry axis. Okay, the radius of the sphere is increased, okay? So radius is increased and mass is constant. So then which of the following quantities would remain constant for the sphere? Okay, so now let's see. We know that torque exterior is equal to 0 because it is rotating freely in free space. So the torque exterior is 0. Okay. So therefore, what I can write this as is the angular momentum will also be constant, right? This is nothing but dl by dt, right? So this will also be constant. So therefore, our angular momentum will be constant. Whereas rotational kinetic energy, moment of inertia depends on the radius, right? Angular velocity also. So Angular velocity also depends on radius. Rotational kinetic energy also will depend on the radius. So therefore, we can say that our angular momentum will be the only thing that wouldn't change. Okay. Yeah. So what were the concepts that we covered in this question is we covered about rotational kinetic energy here. Rotational kinetic energy, we can go through it. Okay. And then we spoke about moment of inertia. And then we spoke about angular velocity. And then finally, we spoke about angular momentum, but we also spoke about torque. So we can see that in one particular question, you have like various concepts that you have to keep in mind. So whenever you come across such questions wherein there are like various other concepts that you need to apply, then make sure that you revisit the other concepts too. It shouldn't be like just on that one topic that, okay, I got the answer, so I'm done. No, you guys should just revisit the theorems or the formulae or the some of the OG problems and everything. So with that, you will get more and more perfect. Okay. Okay. A tube of length L is filled completely with an incompressible liquid of mass m and closed at both the ends. The tube is then rotated in a horizontal plane about one of its ends with a uniform angular velocity omega. The force exerted by the liquid at the other end is what? So this is a 2006 question. Yeah, you guys must be wondering why is there circular motion involved? Here you can see we are using angular velocity. And when do we get anything like angular velocity or angular momentum or angular acceleration? That is when it is closely knitted with circular motion. Okay. So here we'll be considering centrifugal force. And then we'll also be talking about the momentum. And we are supposed to find the force exerted by the liquid at the other end. Okay. Yeah. So first of all, we'll draw the diagram. Okay. What they're telling is there is this axis. Okay. And the tube of length L is filled completely with an incompressible liquid of mass m, and it is closed at both the ends. Then the tube is then rotated in a horizontal plane about one of its ends. So I'm considering this is our end, okay? And then this is rotated something like this, okay? Rotation will create centrifugal force due to which pressure will be created at the other end. Okay, so there will be centrifugal force, okay, and therefore pressure. There will be pressure at the other end, okay. Now the centrifugal force will depend on the distance of the liquid from the axis, as centrifugal force is equal to m omega square r. So let's just say this is where the liquid is, okay. They're taking this here. So it depends on the distance from this axis. Okay, and that is being taken as m omega square r. Let us consider a small part dx of the liquid column. Okay, this is everything is liquid over here. From here, they're considering they're taking a small part dx. Okay, at a distance x. So from the axis, this is at a distance x. Okay, mass of this element will be dm will be equal to m by L dx. How did we know this? We know that thing that dm by dx is equal to m by L. Similarly, I'll go dm is equal to m by l dx. Okay, this is how we'll write it. So force exerted on this element would be df. So we got this, right? This will be the centrifugal force usually. So for this particular small part, our force would be df will be equal to dm omega square x. We are not taking r because we are taking the distance from the axis, right? And for this dx element, it is x over here. So we'll be writing that. So from x is equal to 0 to L, we'll integrate it, okay? So therefore, we'll write it as 0 to F df is equal to m by L. M and L are constant. So we'll remove it, take it outside. Omega square x dx, right? I can remove omega square also. Yeah, I'll write it over here. Yeah. So we'll get it as df 0 to f will be equal to m by L omega square 0 to L x dx. So that will be x square by 2, right? That will give us x square by 2. So that will be ml omega square L square by 2. Because it will be 0, on the other hand, it'll get cancelled. Because anything you multiply with 0 will be 0, right? So this is what you'll get. So again, you will cancel this and this. So you'll get m omega square L by 2 as your answer. And that would be our option D. Here you can see that there are many confusing options over here. This, and this. Okay. So if you make a calculation mistake, you might end up correcting this one, and but then this would be the wrong answer. Here you can see that there is L square, the square is on L and not omega. So this is one of the silly mistakes that we might do because of the time constraint or stress or anything. So we need to make sure that once you calculate the answer, make sure that you take it on the correct option and not mess that one chance up. Okay, moving on to the next question. A mass M is attached to a thin wire and whirled in a vertical circle. The wire is most likely to break when. Okay, so this is one of the questions that we've done before. So what we'll do is, again, visit this. This is a concept of tension. Okay, the circle is concept of tension and string and circular motion. Okay, so let's just say this is the string. Okay. So, and this is the 60-degree angle. For now, I'll take it as theta. So here we can see that at this point, we have mg. And then this splits into mg cos theta and mg sine theta. So therefore, this is the tension. So the tension is not the maximum. Over here, what happens is theta will be equal to 0 and tension will be equal to mg. So the wire is most likely to break when it has the more the tension. So therefore, the mass is at the highest point. If the mass is at the highest point, tension will be equal to 0. So there is no way the string will break. The wire is horizontal. No, it won't break. The mass is at the lowest point. Yes, this is the lowest point, and we can see that we have maximum tension in the string at that point. Inclined at an angle of 60 degree. This is the same mg cos theta would be the only net thing. So therefore, our option is C. That is correct. There's also another way to look at this approach. Here we can see that if there's a velocity v here, there is t over here. So I can write this as t minus mg. Why is it minus? Because they are in two different directions, right? T minus mg is equal to mv squared by r. This is the centripetal force, okay? So therefore the tension will be what? Mg plus mv squared by r. And velocity will be maximum. Velocity will be maximum at the lowest point. Yes, makes sense? Okay. A car is negotiating a curved road of radius r. The road is banked at an angle theta. The coefficient of friction between the tires of the car and the road is ms. The maximum safe velocity on this road is. Okay, this is a question of banking and friction related question. Okay, so this is one of the topics that we'll come across in the forces and friction topics. So we usually, most of them usually neglect this, but then this is one of the topic that we actually need to work on, because here we will be having friction, and then we'll have maximum safe velocity, curvature. So it basically involves too many topics. There are too many small topics that have been combined to make this one. So therefore, we must focus on this one. So what they're telling is the road is banked at an angle of theta. This is theta, okay? And then a car is negotiating a curved road, okay? So this could probably be curving over here, okay? So that the radius is r. And then the coefficient of friction is equal to ms, right? So we'll approach this like v squared max by rg. This is the formula that we've learned, right? That is equal to always mu s. So basically ms is nothing but mu s, okay? Mu s plus tan theta by 1 minus mu s tan theta, okay? So that will give us yeah. So that will give us V max will be equal to root of Rg. That will be again mu s plus tan theta divided by 1 minus mu s tan theta. Okay. So this will be our option B. Yes? Okay. What is the minimum velocity with which a body of mass m must enter a vertical loop of radius r so that it can complete the loop? Okay, so this is also one of the string tension related concept that we will be going through. So what it says is there is a minimum velocity, okay, through which if you give it a push, it will complete its loop and then come back to this position. So we know that V is equal to root 5 GR is the minimum velocity with which It has to be which the body must possess at the bottom of the circle so as to go around the complete circle, right? Yes, so moving on to the next question. Two stones of mass m and 2m are whirled in horizontal circles. The heavier one is in radius r by 2 and the lighter one in radius r. The tangential speed of lighter stone is n times that of the value of heavier stone when they experience same centripetal forces. So this is the 2015 question. So what they're telling is one thing that we need to keep in mind is same centripetal force. So this is the most important key that we can hop on to. So directly I'll equate them. So it has to be like m v1 square by r1. R1 is r by 2. Okay. So this is heavier one. So it is 2m. That will be equal to m. Okay, let's just make it. Yeah. v2 square by r. Okay. So this will be 4. M gets cancelled. R gets cancelled. So 4v1 square is equal to v2 square. v1, 2v1 will be equal to v2. Right. So this is what we got. So therefore, n will be equal to 2. Option D is the correct answer. So there is a derivation for this question. So what we can have is, so this is the string, this is the body, okay? Let's just say we give it a velocity v. At that point, we are considering tension is equal to 0. And then we are also telling that mv, finally, let's just take, okay, let's make this u and let's take this v. So we can tell that mv square by r will be equal to mg, right? This is mg here. And at this point, it will be mv square by r, right? So I can conserve the energy like half m u square is equal to mg into the height would be r plus r. That will be 2r. So mg 2r plus half m v square. Okay. So you'll get it like half, just remove the m's. So u square by 2 will be equal to 2gr plus v square by 2. And that will further be written as, over here also we had it like square will be equal to 4gr plus, I took the 2 over here. So 4GR plus V square. Okay. And again, that will give us, we know that over here we had it as 4GR plus GR, right? Over here, from here, I'm getting that here. V square is equal to GR. So I'll get it as U is equal to root of 5GR. Okay. So this is the derivation. So instead of deriving it then and there, this is something that you can remember, right? Okay. Moving on to the next question. A car of mass 1000 kg negotiates a banked curve of radius 90 meter on a frictionless road. If the banking angle is 45 degree, the speed of the car is. Okay. So again, this is a banking and friction concept. Right? So we'll write it as, for banking, tan theta is equal to always V square by RG. And we have been given it is tan 45 degree. Tan 45 degree is equal to V square by RG. V square is something that we need to find. And R is 90 meter. It is a frictionless road. That's why we're not considering the loss. G is again 10. So you will get it as 1 is equal to tan 45 degree is nothing but 1 V square by 900. So that means V is equal to 30 meter per second. So this is our answer. But then if the friction was present, then it would be the safe velocity that we calculated. It would be what? Once again, it is RG into mu plus tan theta by 1 minus mu tan theta. So this should be the formula if they give that there is friction that exists. Okay. Moving on to the next question. A 500 kg car takes a round turn of radius 50 meter with a velocity of 36 kilometer per hour. The centripetal force is. Okay, so centripetal force, again, this is a straightaway question. So basically, it is nothing but mv square by r. So I'll write this as m is 500 kg and then velocity is 36 kilometer per hour. So I need to convert it into meter per second, kmph, right? So if I multiply it 5 by 18, you'll get it as 10 meter per second. So v square is 100 by r, radius is 50 meter. So 10, so you get it as 1000. Yeah, they have given a body of mass 0.4 kg is whirled in a vertical circle making 2 revolutions per second. If the radius of the circle is 1.2 meter, then the tension in the circle is 1.2 meter. Then the tension in the string when the body is at the top of the circle is. So the mass they have given as 0.4 kg. And then the frequency they have given it as 2 revolution per second. The radius is 1.2 meter. So what we'll do is we'll write it as V is equal to omega r, and that will be 2 pi n into r. So that will be 2 into 3.14 into n is 2 into r is 1.2. So this will be the product 15.0.8 meter per second. Then what do we do is the tension in the string when the body is at the top of the circle is basically nothing but mv square by r minus mg. How do we do that? So basically this is the top and this is the tension over here. This is mv square by r and this is mg on the body. Okay, so basically from here you will get, this is the free body diagram for this. So you get this, substitute the values and then you'll get it as 41.56 Newton to be your answer. And that is our option A. Okay, so our next question is, a particle of mass m is moving in a horizontal circle of radius r with uniform speed v. When it moves from one point to a diametrical opposite point, its kinetic energy changes by mv square by 4. Momentum does not change. Momentum changes by 2mv. Kinetic energy changes by mv square. So here we need to calculate momentum and kinetic energy to know which is the correct option. Okay, so on the diametrically opposite points, velocities have same magnitude but opposite directions, right? So let's just say this and this, or even this and this. Okay, so here the velocity magnitude will be the same, directions will be opposite. So basically what will happen if we talk about the change in momentum, it'll be first mv minus of minus mv. This is final. Let's say this is initial. So you subtract it, right, for change in momentum. So that will be mv plus mv. That will equate to 2mv. So with this, you got the answer to be option C. Okay, moving on to the next question. When milk is churned, cream gets separated due to. Okay, so here this is a very subjective question. Okay, so we all have churned milk so many times, right? Everyone has done that once in your life. So cream gets separated from a churned milk, not due to centripetal but due to centrifugal force. Okay, so centrifugal force is actually a pseudo force that is equal and opposite to centripetal force. Centripetal force can be mechanical, electrical, or magnetic force. Okay, so basically our answer would be centrifugal force. Of course not frictional force, of course not gravitational force. If we would actually think, it would be either between centripetal or centrifugal force. But one thing that we need to remember is centrifugal force is a pseudo force and it is equal and opposite to centripetal force. Okay, so here are a few things that we can actually keep in mind. Okay, so there is a misconception that, centripetal force is directed towards the center of an object's circular path, while centrifugal force is directed outwards. But then only one of these is real force. Okay, so as I told, only centripetal force is a real force. What do you mean by pseudo force? Pseudo force is basically a feeling or a push that we feel. Okay, so it's more like it does not exist, but you feel a force. Okay, it's an apparent force. So basically, when a car takes a sudden turn or a roller coaster makes its plunge, the human bodies inside are already moving with some velocity in a particular direction. According to the law of inertia, these bodies initially resist changing their velocities. Okay. Passengers are still moving forward in space when the car starts to go left abruptly. So rather than being thrown right, the car is actually crashing into them from the left as it suddenly moves. Once their bodies catch up and start moving to the left, the crashing sensation ends. So basically, that momentary sensation that we feel is nothing but centrifugal force. Yeah. Okay. So this is one of the thing that we we should focus on, because we tend to get confused between what is actually centrifugal force and what is centripetal force. This is one of the example wherein they ask us, when the milk is churned, what actually gets the cream separated out. So basically, like I gave you the example of the passengers getting thrown out. So you're churning it, okay, over here, and this is the milk container. Let's just say this is the milk. So here you're rotating it. So there is a sensation being produced in this direction. So therefore the cream gets separated out. So therefore it is the centrifugal force and not the centripetal force. Okay. So what did we cover today? So we've covered that about momentum, change in angular momentum, kinetic energy. We also had a question on Planck's constant. We had a question on centrifugal and centripetal force. And then we also had a few questions on banking concepts, right? So I was thinking, let's derive the banking concept, okay? So firstly, we'll start with, okay, so let's just say this is the theta. So here I have mg, and then our normal would be this side, okay? And then this side I have my n sine theta, and here I have my n cos theta, okay? Yeah. So basically, what I can say is total upward force, that is n cos theta, is equal to mg plus f sine theta. And what is f over here? Our friction. Okay, this is our friction here. Okay. Yeah, so I can write this as mg is equal to n cos theta minus f sine theta. So this is my first equation. Similarly, I can write that we have a circular motion, right? There is a circle in which it is moving. So I can write that mv square by r, centripetal force, mv square by r is equal to, that will be the moving force, that is n sine theta plus f cos theta. That will be our equation 2. Okay. So dividing equation 1 and 2, you'll get it like v square by rg is equal to n sine theta plus f cos theta divided by n cos theta minus f sine theta. Now we know that f is equal to mu s into n. N is our normal. So we'll substitute that over here. So you'll get it as mu s n cos theta. Similarly, mu s n sine theta. So what you can do is remove the n and then you can write it directly as v square by rg is equal to sine theta. Okay, I'll just use the next. Okay. So I can write it as v square by rg is equal to sine theta plus mu s cos theta divided by cos theta minus mu s sine theta. Okay, so I can further write this as, if I divide it by cos theta, okay, I multiply and divide it by cos theta, I'll get it as tan theta plus mu s by 1 minus mu s tan theta. And this is what we have used before. And if they ask for safe maximum velocity, we found it to be rg tan theta plus mu s by 1 minus mu s tan theta. So you can see that by just remembering the formula, you are saving so much amount of time of this derivation and everything. So I'll be wrapping this up by telling you guys, there are few certain questions that you need to practice it so much that you'll have the formula ready in your mind anytime you need it. There might be questions wherein finding the velocity would just be one of the tasks. So rather than wasting your time deriving it completely, practice the derivation so many times that you'll remember the final answer. Okay, so with this, I'll be concluding this session, and I want you guys to go back, revise everything. Just any topic pops up, go back, visit the questions, visit the formulas, try out some basic formulas from basic questions from that particular concept, and make sure that you solve it all on your own. If you don't get it, then refer to the videos, because once you watch this video, you'll have it in your mind that, okay, I need to solve it in this way. But later, after watching it, after like 2 or 3 hours, try solving all of these on your own and then refer back if you find yourself getting stuck. So with this, I'll be concluding this session. Thank you so much.